Here's a puzzle that fools almost everyone. Take a reel of thread, set it on the table and pull the thread. Pull gently at a low angle and the reel rolls toward you. But now pull the thread more upward and suddenly the reel rolls the other way, away from you. Same reel, same thread, what changed? There's a precise angle where the reel switches direction. Can you figure out what it is? Let's set up the problem carefully. We have a reel with outer radius capital R resting on a flat surface. Inside, the thread wraps around a smaller hub with radius lowercase r. The thread exits from the hub and we pull it with a force F at some angle theta above the horizontal. The reel can roll without slipping on the surface. Our question: at what angle theta does the rolling direction flip? Let's identify every force. Gravity pulls the reel down. The normal force pushes up. And at the contact point with the ground, there's static friction. That friction is the only horizontal force on the reel, so it alone decides which way the reel accelerates. But which way does friction point? That depends on the torques. This is where it gets interesting. Here's the key insight. Take torques about the contact point P where the reel touches the ground. Gravity and the normal force both pass through the center, so they produce equal and opposite torques that cancel. Friction acts right at point P, so its moment arm is 0. That means only the pulling force F creates a net torque about P. The direction of rolling depends entirely on which side of P the force's line of action passes. Watch the line of action of the pulling force as we change the angle. At a low angle, the line passes to the left of the contact point. The torque about P is clockwise, and the reel rolls forward toward the pull. Now increase the angle. At some critical moment, the line of action passes exactly through the contact point. 0 torque, no rolling at all. Go beyond that angle, and the line passes to the right of P. The torque flips to counterclockwise, and the reel rolls backward. So what is this critical angle? The force is applied at the hub, a distance r from the center. The contact point is a distance r directly below the center. When the line of action of F passes through the contact point, simple geometry gives us cosine of theta c equals r over r. That's it. The critical angle is the arc cosine of the ratio of the hub radius to the outer radius. Let's see it in action with r equals half of r. The critical angle is arc cosine of 1/2, which is exactly 60 degrees. Pull below 60 degrees, the reel rolls toward you. Pull above 60 degrees, it rolls away. And right at 60 degrees, the reel slides without rotating. Beautiful. So the answer to our puzzle is elegant. The critical angle is theta c equals arc cosine of r over r. Below this angle, the reel rolls forward. Above it, backward, all from a single torque argument about the contact point. Next time you see a roll of tape, give it a try.